So this is part of our JMP academic series, Biostatistics and Health Sciences. If you are new to JMP, JMP is a family of products, and we just released version 12 of JMP, which has a variety of features for data analysis and for data visualization and modeling. And we have a professional version which has some advanced features, including one-click bootstrapping and exact measures, but also some advanced tools for building predictive models. So I will primarily be using JMP 12 throughout this session, although there are a couple of tools that I'll use, including mixed models that are available in JMP 12 Pro. If you are part of a university, universities have access to both JMP and JMP Pro through the academic suite, and this is for Mac and Windows. And I'll be using a Mac throughout this session, although everything I show you on the Mac you can also do on the Windows machine. There are two other products I should mention which we won't discuss today directly. The first is JMP Clinical, and JMP Clinical is for clinical trials and things like risk-based monitoring, and this is in fact a capture from the website jmp.com/clinical, and also JMP Genomics. And both clinical and genomics is a bundle of JMP with the JMP workflow running the SAS code in the background. So JMP Genomics is running SAS Genomics in the background. So I won't talk directly about either of these two today, but if you're interested, the links are provided here. So what is JMP? Well, I'm going to use a journal throughout this session, and the journal contains links to data sets just to expedite things. And I've also included a little bit of code. So I've got some data, obesity and diabetes, and this is from a public website for the CDC. And I'm going to generate a little bit of output, and think of this as your sneak peek at what JMP is all about if you're brand new to JMP. So I've generated some output off of a data table. This data table has 3,100 rows, 10 columns. The icon on the side next to the variable names indicates the type of data that we're looking at. So anywhere where you see blue triangles, this indicates that we have continuous data, where calculating an average might make sense. Anywhere you see the red bars is for categorical data or nominal data. So I've generated some output using just out-of-box platforms. This first output is from the first option in the graph menu called Graph Builder. JMP includes geographic mapping, and this is a nice vehicle for plotting data geographically. So here we're looking at the estimated percent obesity, and we can see that in some regions the obesity rate is higher than in other regions. Under the Analyze menu, we see options for analyzing data, and every analysis in JMP will produce summary statistics and also graphics. The graphics are all linked, so if I select bars or values in one graph, the corresponding values are highlighted or selected in every other graph and also back in the data table. Every window in JMP, every analysis window, will have red triangles with additional options, and we'll be exploring these as we go along. The key is that these options are context-based, so they update based on the type of variables that we've selected or based on the data structure. Within JMP, there are a variety of tools for dynamically exploring your data. So here we're back to the Graph Builder, where we're looking at the relationship between diabetes and percent obesity, and we've added a data filter. And a data filter is a nice tool for pulling in other variables. So here we're looking at the relationship by state, and as I select each state, the graph automatically updates. If I hold down the Control key, I can add additional states. So throughout JMP, we have very nice dynamic tools for interacting with our data and exploring statistics or graphs that have been created. And if we'd like to view data in multiple dimensions, there are tools such as the bubble plot. So here I'm looking at those same two variables, diabetes and obesity, and each point represents a state, and we've sized the bubbles based on the population within that state. And notice that as I hold my mouse on top of any point, we see the values corresponding to that point. And this is called the bubble plot. This is an option under the graph menu. And again, all of this is driven from the data table. So just a little bit about the setup of JMP, and I'll pull this data set back up. In the data tables, you'll also see these red icons. These red icons provide additional options based on wherever you are within the data table. When you first open JMP, you'll see a home page, and the home page is available both on the Mac and the Windows machine, and the home window is there to help you keep track of your work. So here I see a list of recently used files and a window list for files or analyses that are currently open. And this is used for navigation. When you first open JMP on Mac, you'll see a JMP Starter window. The JMP Starter window, which is available from the Window menu, provides shortcuts to analyses within JMP. So if I click through under Category, we see a description of what's available from each of the analysis options. When you first get started with JMP, you'll also see what's called the Tip of the Day window. And if you start using JMP, I'd recommend at some point that you read through these. These provide nice short tips for navigating around in JMP. Now our menus in JMP, if we look across the menus, we see things like File. And File is for open, close. You can export data. You can connect to databases, and there's a new query builder for writing SQL queries to pull data into JMP. We are connected to SAS, and you can pull data in directly from the internet. Edit is for things like cut, copy, and paste. And as we're going along, I'll talk a little bit about paste with column names. This allows you to copy data in from Excel and to paste the first row from Excel into JMP as the column headers. Tables is for data table manipulation. So for example, we want to summarize our data, create a subset, sort, stack, or split. Rows relates to rows, and a feature that we'll talk about here is the data filter. And I showed an example of this earlier, the local data filter. Well, the data filter from the rows menu is a global data filter that applies to all open analyses and to the data table. So we'll visit this in a few moments. Columns provides options related to columns, and a couple of features that I'll talk about today. One in particular is Columns Viewer. And Columns Viewer is a nice tool for summarizing your data. Under Utilities, another tool that we'll talk about if we have time is Recode. And Recode is used to clean up your data. This is for cleaning up categorical data. Under DOE is tools for designing experiments, and there are a wide variety of experiments available, or experimental types available. And at the very bottom, this is where you'll find the calculators for sample size and power. Most of the time in JMP, you're going to be under the Analyze menu and under the Graph menu. And the way we think about data analysis in JMP is based on the number of variables that you're looking at. So for distribution, we'll see graphs and statistics for one variable at a time, so univariate graphs and statistics, including hypothesis tests and confidence intervals. Under Fit Y by X, we'll see tools for analyzing two variables at a time. So this is a two-sample t-test and ANOVA, crosstabs and chi-square, including relative risks, odd ratios, tests for proportions, regression, simple linear regression, and also logistic regression. Matched pairs is for a paired t-test. Tabulate is our version of a pivot table, and we'll see this in a few moments. And as we go down, we see more advanced methods. Fit model is for building linear models, and it's also for building mixed models and logistic regression models, and for models involving reliability and survival data. Modeling includes some advanced modeling methods, and we'll spend a little bit of time talking about multivariate methods, such as correlations and principal components. And under reliability and survival, we see tools for dealing with non-normal data or time to event data. So we'll spend a little bit of time under the Analyze menu. And under Graph is tools for exploring our data, where we're fundamentally interested in dynamic exploration of the data. Now I'll point out under the Help menu that there is searchable help under Books, and there's a vast sample data directory, and most of the data sets that I'll be using throughout this demo are available from the sample data directory. I'll also be posting this journal into our user community once the session is over. So before I proceed, I do want to point out that there are resources available elsewhere that link directly to what I'm covering. The JMP Learning Library provides one-page guides and videos for performing specific tasks within JMP. So everything that I'm going to cover today, there are other resources directly available. Within the Learning Library, if you choose a category, within that category you'll see a listing of topics, and for most topics you'll see a short video and a one-page guide where we try to provide most of the information that you might need in order to understand that topic. And these tools are all summarized at jmp.com/teach. So you'll see a complete listing of tools for learning JMP and additional tools for teaching JMP. So what are we going to talk about today? Well, I'm going to start with tools for summarizing and visualizing data. Then we'll move into data analysis for one variable at a time, two variables at a time, and we'll see quickly how to build a model within JMP. We'll talk about some of the multivariate tools that are available. We'll introduce tools for reliability and survival analysis. We'll see how to build mixed models within JMP, and we'll talk about how to save work and get your data into JMP. All right, so let's talk about data summary and visualization. I'm going to open the VA lung cancer data, and this is available from the sample data directory. The key variable of interest is time, and this is survival time in a cancer study where we're looking at different cell types, different treatments, whether the patient had had prior treatment or not, the age at the point of entry into the study, the time between being diagnosed and entering the study, and KPS, which is a measure of quality of life. And the higher the value, the higher the quality of life. And there's also a sensor variable. I'm going to ignore the other variables and focus on these variables. And if I have data like this and I want a nice initial sneak peek at the data, I'll use Columns Viewer. Columns Viewer simply allows me to select the variables of interest. And if I want to be able to see percentiles or quartiles, I'll select Show Quartiles and then select Show Summary. This is particularly useful if you have large data or you have data that you're not overly familiar with. For each of the variables, you see some summary statistics. If the variable is categorical, you'll see the number of categories. So we have 4 cell types, 2 treatments, and 2 categories for prior. If the variable is continuous, you'll see the min and the max, and then summary statistics. And this is a nice way to view if you've got potential data quality issues. If you're missing values, you'll see N missing appear. In this case, for time, we see a minimum of 1 and a max of 999. And this is a good indication that either we have censored data or that we're using a missing value code. And this is something that we would address in the analysis. For censor, we see values 0 and 1. And this is really categorical data. But here we're simply using a 0-1 censoring code. Now if we'd like to graph this data, I can select all of the variables, and notice in the background these columns are being selected. All analyses in JMP are linked to every other analysis. I can select the distribution platform. If I don't want to access this through the columns viewer, I can also launch the same analysis from the distribution menu. So I'll simply click to select variables, and I'll use the Shift key to extend the selection and select Y columns, and then OK. For continuous variables, we see a histogram, a box plot, and summary statistics. For categorical variables, we see a bar chart and frequency distribution. The default view in JMP will be a vertical view, and if you'd like to change that, under the red triangle next to distributions, use the stack option. If you'd like to change that for every future analysis, under the JMP menu or under File on the Windows machine is an option Preferences. And under Preferences is a listing of platforms. And if I select Distribution, Stack, and Horizontal, and then click OK or Apply, then the next time I run this analysis, the histograms in the output will display in a horizontal layout rather than a vertical layout. For summary statistics, we show default statistics, and this is something that can also be changed within preferences. For the list of summary statistics, anywhere you see a red triangle, there are additional options. So if I'd like to display additional statistics, there's a complete list that I can select from. Under the red triangle, we see additional options. So for example, for time, I might want to ask for a normal quantile plot, do a hypothesis test, ask for an interval, or if I'd like to explore the distributional fit, there are a lot of different distributions that I can fit to this data. If I select all, continuous fit all, JMP will fit all of the available distributions and will help to select the best fitting distribution. In this case, JMP selected the Weibull distribution based on the AICC or IKK information criterion, and the little c stands for corrected. For any distribution you fit, you'll see additional options such as goodness of fit and quantiles. So this is summarizing data using the distribution platform, and we'll return to this platform in a moment when we talk about hypothesis testing. If we'd like to be able to summarize multiple variables at a time, we use Analyze, Tabulate. And Tabulate is a form of a pivot table where we have two drop zones, a drop zone for rows and a drop zone for columns. I'd like to summarize time, so I'm going to grab time and drop it in the drop zone for columns. Notice that it's summing all of the values within that column, and we can click and drag to replace sum with other values. In fact, I'll just drop these other statistics right on top of the word sum. So now we're seeing the overall mean and standard deviation. The other drop zone is now a small box, so if I'd like to break this down by other variables such as cell type, drag and drop onto that box, and we're seeing a sum by cell type. To add additional variables, we can click and drag, and notice there's a little blue bar, and that little blue bar indicates that I can build a hierarchy here. If I release prior in front of cell type, then it'll sort first by prior, then by cell type, and if I click and drag to the other side of cell type, then I've changed the hierarchy. In fact, we can add additional variables to this hierarchy. To change the number of decimal places that displays, on the bottom under Change Format, use Same Decimal Format, and then Fixed Decimal. We call this panel on the side a Control Panel, and when you're finished creating this tabular summary, click the Done button, and this produces the summary. And then to save your work in any analysis in JMP, under the red triangle, you'll see a script option. And the option Save Script to Data Table allows you to save the keystrokes that generated this analysis to your data table. So notice I've got a new Tabulate button here. And if I run this script, it'll regenerate the analysis exactly as it saw it. If I'd like to be able to save this table elsewhere, there are a couple of other options available. For example, making a data table, we'll save this as a new data table. If I want to be able to go back and make additional changes, I could turn the control panel back on. Or if I'd like to copy and paste this into another program, across the top there's a fat plus sign, and we call this a selection tool. And if you're on a Windows machine and don't see this toolbar, click the Alt key on your keyboard. The toolbar will hide by default, and this is a preference that you can set. So if I use the selection tool and select this output and use Edit, Copy, if I go to Word or whatever program I'd like to paste in, if I simply use Edit, Paste, then it's pasted in an editable format. An alternative is to paste it as an object. Here I'll use Edit, Paste Special. And on a Mac we use the option PDF. On a Windows machine we use the option Enhanced Metafile. And this will paste it exactly as we saw it in JMP. So this is Tabulate, and then a graphical version of Tabulate is under the Graph menu, and it's called Graph Builder. Graph Builder also has drop zones, but it has additional zones for stratifying our data or adding additional information to the graph. We'll select time as the Y variable, treatment as the X, and across the top we see additional graph types or graph elements. And as I click through these, notice that the graph automatically updates. Instead of having treatment as an X, I'll select time and then age. In this case, we have some additional options. If I've got a continuous variable versus a continuous variable, I can do things like fit a least squares regression line, fit a contour, or density ellipse. So the graphs will update based on the type of data that you've selected. So let me go back to time, and in this case I'm going to look at time versus cell type. This is also a platform where you can add multiple dimensions. So I might want to stratify this data by, for example, treatment. And as I drag a variable to a different zone, notice that the graph automatically updates. From this platform, there are two tools that I'd like to illustrate for adding additional information. And I mentioned one of these earlier, and that's the local data filter. To access this is available from the script menu towards the bottom, local data filter. And it's available from every analysis in JMP. The local data filter is used to interact with a graph by adding information based on another variable. So here I'm looking at treatment and I'm looking at cell type, but I'd like to look at this based on whether or not they had a prior treatment. As I click in each of these categories, notice that the graph automatically updates. So this allows me to explore a graph or analysis based on values of another column. Another tool that I'll just mention is called the columns viewer. If I have a lot of variables, the columns viewer allows me to switch out one variable, so for example cell type, with another variable. And I'll select cell type and prior here. So here I can toggle between the different variables in the analysis. And again, this works from any platform. Now, I mentioned the local data filter. If we'd like to filter both the open graph and the data table and every other analysis based on another variable, under the rows menu is the data filter. And this is the global version of the data filter. If I select the data filter from within a platform, the local data filter only interfaces with that open graph. Let me close this. And additional tools under the graph menu that I'll just mention, a scatterplot matrix and a scatterplot 3D, parallel plot, cell plot, and towards the bottom you see tree map and some additional charting tools. So let's move now into data analysis. And data analysis in JMP is based on the variables that you select. If you're interested in analyzing one variable at a time, we use the distribution platform. If you're interested in analyzing two variables at a time, we use fit y by x. And if you're interested in exploring more than two variables at a time, or building models involving more than two variables at a time, we use fit model. And I'm going to open up this data called fitness data. And in this case, we're interested in exploring the oxygen uptake in a study involving males and females of different ages and different weights. We're also measuring some fitness measures, the time to run a mile, run pulse, rest pulse, and max pulse. Since this is my response, I'm going to click and drag and move this to the beginning of my data table to make it a little bit easier to find. Let's go to distribution to analyze this one variable at a time. Again, within distribution, here's oxy. I'll skip name since that's just an identifier. I'll select the other variables. Again, everything in jump is linked to everything else. And I'm going to turn on stacked. And let's say I'm interested in performing a hypothesis test for Oxy. I see on the side under summary statistics, jump is reporting out a 95% confidence interval for Oxy. And by the way, anytime jump reports statistics, if you'd like additional information on what is being reported, if you take your mouse and you hover on top of that statistic, you'll see a little help box appear. So in this case, jump is defining this as the upper 95% mean, and it's giving us a little bit more information on this. An additional form of help is the question mark. If you take the question mark on your toolbar and you drop this anywhere you have questions, jump will take you to the interactive help files. So let's talk about hypothesis testing in jump. Under the red triangle, you won't see the word t-test, but if you scroll down as you scroll through the menu items, jump will provide information on what each of those menu items provides. So test mean is where we can perform a one sample t-test or one sample z-test. And within jump, anytime you want to perform a non-parametric test, the non-parametric tests are performed from the same platforms as the parametric tests. So here we see we can perform a t-test, a z-test if we specify the standard deviation, and then the non-parametric equivalent is provided at the bottom. So I'll test the hypothesis that the oxygen uptake is 50. And any test within jump, let me make this a little bit smaller, you'll see a graphical representation of the test, and anywhere where you see prob greater than something, this is how jump represents the p-value. Our test statistic is the t-ratio, and we're comparing that t-ratio to a critical value from the t-distribution. So the value that falls after the prob greater than refers to that reference distribution. So prob greater than absolute value of t is the p-value corresponding to the two-tailed test. The curve at the bottom is trying to graphically represent this test. It's centered at our hypothesized value of 50. The curve represents the distribution of all sample means we might observe under the null hypothesis. The red value is drawn at our observed sample mean. And the blue area in the tails corresponds to the p-value. For a one-tailed test, the p-values that you'll see correspond to the sign in the alternative hypothesis. So here, prob less than t corresponds to the alternative hypothesis that the mean is less than 50. Now, if you struggle a little bit with p-values, under the red triangle are a couple of animators. There's a p-value animator and a power animator. The p-value animator allows us to explore this static graph by changing the distance between our hypothesized value and the observed sample mean. So as I click on the dragger, or the grabber, this little box at the top, I can increase the distance between these two values and observe what happens to the t-ratio and also to the p-value. So it's a nice way of getting your hands around p-values. Now what if I've got categorical data? Let's say that this is a random sample of data and I want to be able to test that my distribution of males and females matches the population. If I click on the red triangle under test probabilities, I can specify the hypothesized probabilities. So let's just say it's 0.5 and 0.5. And then by default, jump will perform a two-sided chi-square test, but we can change that to a one-sided. I'll click done. And jump reports two p-values. And again, anytime you see prob greater than something, that's the p-value and the reference distribution. And in this case, the p-values are fairly high. Two types of tests are performed, the likelihood ratio and the Pearson test. Now what if I want to look at one variable against a second variable? In this case, I'll use fit y by x. And we'll start by looking at cases where we have a continuous response, Oxy. The key in the bottom corner indicates what type of analysis jump will perform based on the modeling type of the variables that we've selected. if oxy is the response, on the side of this little key, this corresponds to the modeling type of the y variable or response variable that we've selected. There are two options for a continuous response: bivariate, which is correlation and regression, or one way, which is a two-sample t-test and ANOVA. I'll select sex as an x, and the axis or the key across the bottom corresponds to the modeling type for our x variable. So there are two options if we have a categorical x: one way, or contingency table, which includes chi-square and crosstabs. So in this case, I've got a continuous variable versus a categorical variable. JMP will take us to the one-way platform. If I add a second variable, such as age, JMP will perform all possible tests, and in this case we'll look at oxygen uptake versus age. I've got a continuous variable versus a continuous variable. JMP will take us to the bivariate platform. So JMP has performed two separate analyses, and if I click on the red triangles, you see that the options update. On the one hand, I've got means ANOVA pooled t for the pooled t-test, or a t-test if I don't have the assumption of equal variances. The non-parametric tests are available, unequal variances. JMP does include robust methods. On the other hand, we've got a bivariate fit. In this case, we're going to fit a line, which is simple linear regression, or a polynomial, or fit special, which is for transformations for the x or the y. Again, we have robust fits. So the options will update based on the modeling types of the variables that you've selected. To perform a t-test, I'll select t-test. And by the way, if I had 3 or more categories, this first option will update, and instead of reading means ANOVA pool t, it'll simply read means ANOVA. In the t-test, again, we see a graphical representation of the test. Here the hypothesis is the mean for females equals the mean for males, or written another way, that the mean difference equals 0. So the curve is centered at 0, and the observed value of the difference is drawn at the red line. The difference that we have observed is minus 5.08. We see a confidence interval for that difference and a p-value. Additional options within this platform are available, and some nice graphical displays are available under display options. For the bivariate fit, and I'll use this little gray triangle to tuck this away. In this case, we can fit a line, and when we fit a line, you'll see that additional statistics are added below. We see the fitted equation for the line, the summary of fit, the test for significance of the model, and the parameter estimates. And one thing I'll point out here is that any table in JMP, for example this parameter estimates table, is a live table. If I right-click in the middle of the table and select columns, there are additional options that are available. So for example, if I'd like to see the confidence intervals for the parameter estimates, I'll select lower 95% and upper 95%. For this fitted line, there are additional options available. I'll click on the red triangle next to linear fit, and there are confidence limits. I can ask for residuals. In fact, I'll go ahead and plot the residuals here, and this will produce several residual plots. If I'm looking for correlation within this platform, correlation is tucked under density ellipse 0.95. And we represent the strength of the correlation as these ellipses, and towards the bottom we'll see the reported correlation coefficient. So this is if I got a continuous response. What if I've got a categorical response? I'm going to open the Titanic passengers data. And in this case, again, this is sample data. We have survived as a response, yes or no, against a number of variables. Within fit y by x, if I've got a categorical response, and categorical could be nominal, which is just labels, or ordinal, which is green bars. My two options are logistic regression and contingency. If I plot a nominal versus an ordinal passenger class, this will take me to the contingency table platform. I'll also select sex, and I'll select one continuous variable. So in the first two cases, jump is going to take us to the contingency output, and in the third case, it'll perform logistic regression. The plot we see is called a mosaic plot, and there's a key on the side, and this provides a breakdown of no, which corresponds to did not survive, versus yes, did survive. And as I hold my mouse over these bars, we see the breakdown of no's versus yeses. Across the bottom, we see the breakdown of passenger class. The width of the bar is the relative proportion of third class versus first versus second. The numbers are summarized in the contingency table. And again, the numbers that are displayed up by default can be updated by clicking on the red triangle. We also see test performed by default. Under the red triangle, we see options like analysis of means for proportion, exact test if you have Jump Pro, and other options. The breakdown of each bar shows us the breakdown of no's versus yeses for each of the passenger classes. If I look at the next plot over, the mosaic plot for survive versus sex, we see a breakdown of yeses and no's, survived or did not survive, versus males versus females. And there are additional options available. So from here I can ask for relative risk, odds ratios, and 2 sample tests for proportions. The relative risk will ask what the response category of interest is. And here I'll select yes. And for any option selected, you'll see additional statistics are reported down below. Here's our odds ratio. And for 2 sample tests for proportions, it allows us to change the response category of interest. For logistic regression, and I'll tuck these other guys away to save some room. For logistic regression, JMP is plotting the probability of no, of did not survive, versus the number of parents and children. This line represents what happens to the probability of not surviving as the number of parents and children increases. And below we see a whole model test. We see some information regarding how good our model is, the parameter estimates, and again, additional options are under the red triangle. And in this case, we might be interested in the ROC curve or the lift curve. And again, we see odds ratios. And one question that often comes up, what if I wanted to plot the probability and model the probability of yes versus no? Anytime you want to change the modeling or the way JMP models for categorical variables, if I go back to the data table, within each column, and here I've got survived, if I right-click on that column and go to column information, there are a number of properties that can be specified. Here I've specified value labels 0 equals no and 1 equals yes. By default, JMP is going to model the probability of whichever value is the lowest. In this case, it's 0. If I want to change this, I'll use value ordering and simply move 1 to the highest level. So now the next time I run that analysis, JMP will model the probability of yes rather than no. This will also take effect in any graph that I've produced. Any graph in JMP will plot the values alphanumerically. Now I want to show one other example. What if you have summarized or tabulated data? And this again is some sample data where we're looking at alcohol consumption versus relapsed. And we've got summarized data where we've got a count of the number of consumed yes, consumed no. If I'm looking at this one variable at a time under distribution, we've specified that the count is frequency. In fact, notice that there's a little count icon here. In any variable, if I right-click here, there are additional options. In fact, I'll right-click at the top, and we've given this variable a role of frequency. If this was turned off, in fact, I think I just turned it off. Let me select no role. If it's not specified as a role variable, I'll go back to distribution. In order to make that take effect, I'll select alcohol consumption as Y and relapse as Y. We need to put count in the frequency field. And this indicates to JMP that this is summarized or tabulated data. And JMP will perform the analysis correctly. If we don't do that, I'll hit recall to bring this up again. Notice that JMP thinks that we have a total of 4 values. So we have to specify the count or frequency in that field in order for JMP to recognize that this is tabulated data. The same thing applies to fit y by x. So if I'm interested in looking at relapse as a response versus alcohol consumption, and I'll put count in the frequency field, then JMP will produce a mosaic plot, and it's able to correctly assign the right counts to each of these categories. And again, from here we have access to relative risk and odds ratios and other tests. Now if I want to build a predictive model, I'll use fit model. And fit model is a very versatile modeling platform, and I'll start by looking at a continuous response. Let's say I'd like to model oxy as a function of these other variables. I'll go to Analyze, Fit Model, select oxy as the response, select each of the variables as an x, and a couple of points here. JMP will parameterize categorical variables for us, so we don't have to create dummy variables. And if I'd like to add an interaction, I'll select the terms involved in the interaction and select cross. If I want to be able to add all possible interactions, and I won't do that here because I've only got 31 observations, if I select all of the variables, degree refers to the degree of the interaction that I'd like to include in the model. I'll select macros factorial to degree. Under personality, we see a lot of different modeling types that are available. Standard least squares relates to ordinary least squares regression. Stepwise regression includes all possible models, and this is for model selection. If you have JMP Pro, you'll see generalized regression, and what generalized regression includes is non-normal response distributions, including Cauchy if we have a lot of area in the tails, exponential, and you also see the zero inflated distributions. And within the platform, you'll see methods for penalized regression, including lasso, elastic net, and ridge. And this is a feature available only in JMP Pro. There's a mixed model platform, and we'll talk about mixed models in a moment. If you're dealing with survival data, proportional hazard, and parametric survival, and also generalized linear model. So let's just look at a basic model where we've got standard least squares regression, and I'll select run. New in JMP 12 is this effect summary table, which provides a high-level view of the significance of the terms in our model. It also provides a vehicle for interacting with our model. So for example, rest pulse here is showing with a high p-value. If I select remove, JMP will remove it from the model and will update all of the statistics and graphs that are produced. The actual by predicted plot shows an overall plot of the significance of our model. The blue line represents the overall mean, and the red line represents the predicted value, and the bands are confidence intervals for that prediction. We see a summary of fit table, the analysis of variance table for the test for the overall significance of the model, the parameter estimates, and effects test testing for the significance of each of the terms. And by default, we've also seen a residual plot. Everywhere in JMP, you'll see additional options under the red triangle. So for example, there are additional estimates. If we'd like to show the form of the prediction expression, we can request it here. One point about the way JMP parameterizes our categorical variables, JMP uses a -1 +1 coding scheme called effect coding to apply a 0-1 indicator coding scheme, select indicator parameterization estimates. Under factor profiling are a lot of tools for visualizing your model, and I'll point out one tool here called the profiler. And what the profiler allows us to do is interact with this model that we've just built. So for example, if I'm looking at the parameter estimates, I see that some of my coefficients are negative. The negative slopes for these lines relate to the negative coefficients. The steeper the slope, the more significant that term is. the vertical lines allow us to interact with the model. So we can change the runtime, for example, and notice how the predicted response changes. So the predicted response is in red with the confidence interval for that prediction. And as I click and drag, I can change any one of these values. And it's showing the prediction at the values of the other variables. It's also a nice way to view potential interactions. So here I've got a marginally significant interaction between sex and age. If I click and drag sex from male to female, notice how the slope of age changes. And likewise, if I drag age to the high level versus the low level, I see that the slope for sex is flipping. Now this same type of modeling is available if I've got a categorical response. Instead of doing ordinary least squares regression, JMP will produce logistic regression. So since we're running short on time, let's talk about some of the other tools available in JMP. And we'll start with talking about multivariate analysis. All of the multivariate tools in JMP are under Analyze Multivariate. The first option, multivariate, allows us to produce correlations and scatter plots. Clustering is hierarchical and k-means clustering, principal components, discriminant analysis, and partial least squares. So let's show one or two of these. I'll open the body measurements data, again from the sample data directory, under Analyze Multivariate Methods, Multivariate. I'll select all variables that are available. And by default, we see correlations. These are pairwise correlations and a scatter plot matrix. Options under the red triangle include pairwise correlations, simple statistics, non-parametric correlations. We can also add color maps and a parallel coordinates plot, and we can launch principal components from here or outlier analysis. If we're missing values, we can also perform missing value imputation from here. Under the scatter plot matrix, we also see a red triangle with additional options. So for example, we can fit a line from here, shade the ellipses, and if we want to change the ordering of these variables, we can click and drag in one cell and dynamically move to change the ordering of the variables that are plotted. For principal components analysis, I'll use this same data. I'm fundamentally interested in predicting mass, but I've got a lot of physical measurements that I know are correlated. I'll select those measurements. And JMP tries to produce the default graphs that we think you might be most interested in. So we see the eigenvalues and a couple of plots. And these plots are also available from under the red triangle. So for example, if I selected loading plot with two components, we see that that's the plot that was selected by default. If I'd like to see more information for the eigenvalues or the eigenvectors, we can request this information here. So we see the same eigenvalues, but now we're seeing the percents and the cumulative percents. Other options include a biplot and a scree plot. From here, I can also save the principal components out to a data table, and this includes imputation if we're missing values. I can launch factor analysis from here, and if you've got JMP Pro, there's a feature, Cluster Variables, which allows you to identify the variables that are explaining most of the variation in this set of predictors. So here, forearm and height measurements explain 74% of the variation in the set of predictors. For survival and reliability, there are a number of features available. In fact, there's a whole platform under the Analyze menu. And for this example, I'll relaunch that VA lung cancer data. So here I'm interested in time. The time to event data, I'll use Analyze, Reliability and Survival, Life Distribution, and I'll ignore the other variables for now. So I'm interested in this time to event. By the way, from here I can look at the distribution of this variable. I can also use this to compare groups, and we'll just focus on the time to event. If you've got censored data, we can select the censoring variable, and I'll click OK. JMP has produced the non-parametric Kaplan-Meier curve. The buttons under Scale allow us to explore probability plots for the different distributions. So notice that the probability plot for Weibull appears to be pretty straight. To apply that distribution, I'll select the box under distribution. In fact, I'll go ahead and apply the original scale. And on the side, we see a distribution profiler, which is a lot like the prediction profiler, and this allows us to explore the probability at a given time. And additional statistics are provided down below. Under the red triangle, we see options for comparing different distributions, fitting a mixture of different distributions, and a variety of different graphs. In fact, here I'll go ahead and select Fit All Non-Negative Distributions. And what JMP does is it fits all of those distributions, and then it selects the distribution that fits the best. So this is the first option under Life Distribution. If I want survival analysis, I'll use a survival platform. And again, same sort of setup. I've got the time to event. I'll select censoring. And here I'll add in a grouping variable. I'll add in treatment type. I can select to plot the failure instead of the survival. And we get the classical survival plot with, again, additional options under the red triangle. To fit a model with multiple predictors, I'll use either parametric survival or proportional hazards, and this fits the Cox models. So I'll build a model with several x's, and again, censor variable. By default, it's picking the Weibull distribution. Again, I'll hit run, and this looks very similar to what we saw before when we fit a model using the Fit Model platform. It's a very quick overview. The last thing I'd like to show is to build a mixed model. If you have JMP, the assumption is that you can only fit a model where you have a structured covariance matrix. So I'll open up some data. Here we're looking at machine and person and rating. And in Fit Model in JMP, to specify this as a mixed model where I've got a random effect, I'll select the response and I'll select the x's. In fact, I'll add an interaction, and we'll specify that person is a random effect, and by definition the interaction is also a random effect. So to specify these two as random effects, under attributes I'll select random effect, and JMP bounces automatically over to REML. You can also do EMS with unbounded variance coefficients or components. And this will give us the variance components along with a fixed effects test. Again, the assumption in JMP is that you have a structured covariance matrix. In JMP Pro, we've added a number of different structures for the covariance matrix. And I'll simply run a saved script to save some time here. So from the mixed models platform in JMP Pro, there are several different repeated structures that are supported. Here we specify the fixed effects. We can specify the random effects, so random coefficients or random slopes, and then the repeated structure. And in this example that's already been built, the repeated structure is time with patient as the subject. And when I run this, then we'll see parameter estimates for the repeated effects, for the fixed effects, and then fixed effect tests with additional options under the red triangle. So very quickly, that's an introduction to our mixed model platform. And in terms of getting data into JMP, we've already talked about how to save your work. I should mention that you can also save as HTML, and you can save as PowerPoint and high resolution. And if you visit our learning library, there are instructions on how to do this. And to get data into JMP, you can use File Open. There is an Excel add-in on a Windows machine to facilitate getting data into JMP. And on both Mac and Windows in JMP 12, there's an Excel wizard that allows you to look at the data first before pulling it into JMP. So what have we talked about today? Well, we've talked about tools for summarizing and visualizing data, including the columns viewer under the columns menu, Tabulate under the Analyze menu, for producing tabular summaries, distribution for summarizing and graphing one variable at a time, and we also saw the graph builder. For data analysis, we focused primarily on distribution for looking at one variable at a time, fit y by x for looking at one variable against a second variable, and then fit model for building models with multiple x's or multiple y's. And this again is also where we produce mixed models. For multivariate methods, we quickly saw a couple of multivariate methods, and all of these are grouped under the multivariate methods platform. And we quickly saw some tools for analyzing time to event data under the reliability and survival menu.